Welcome, everybody. This is the Rotary E-Club of Silicon Valley, and every week we bring you people who are making a difference in the lives of others. As a Rotary Club, we are part of Rotary International, 1.4 million Rotarians and Rotaractors around the world, 36,000 Rotary Clubs, as a matter of fact. And all of us are kind of into how do we make the world a better place? And if you are not in that category, how'd you get in? But hopefully that's just not the case. Anyway, so what we're excited about is finding ways to improve communities locally, globally, and digitally. And as an asynchronous online club, we feel that we've got a special talent for finding folks anywhere in the world, and that ability to essentially work with their time and place to bring their stories to you. So you read about Carling on the way in. If you didn't, feel free to pause if you are watching this as a recording and to read the intro above, or if you are on our YouTube page, to read the intro below, and then come back and restart the video. But she is going to tell us about the confluence of AI and recycling and making the world a better place. And as you saw from the bio, she's cool, which is one of the requirements for speaking to us. So, Carling, having been vetted, welcome. You are welcome as a part of the Rotary E-Club of Silicon Valley today, and we're happy to share your story.
Well, thank you so much, Rushton. Thank you all for being here today. And for those of you watching the recording, I'm excited to have the opportunity to share a little bit more about how artificial intelligence is impacting the recycling system. I know that in the last year, you've had someone speak to your club about recycling, maybe from the city of San Jose, if I'm remembering correctly. And I watched that just to make sure there wasn't going to be too much overlap, but it seems like there was a focus kind of on consumer behavior as it relates to recycling. And she also gave a really good overview of some of the macro trends, like China's national sword policy, that are impacting recycling. So I'm not going to cover any of that, just to not be redundant, and I'm going to focus a little bit more on the role that technology is playing in modernizing our recycling system. So just to set the stage, despite the high demand for recycled content that's coming from brands and packaging producers, we're losing a massive amount of value to the tune of billions of dollars each year to the landfill. And this is due to the economics and the complexity of material recovery. At AMP, our mission is to enable a world without waste. And I know that's very lofty, so I'm going to break down how we're doing that in a little bit more practical terms. We are working to improve the economics and the efficiency of recycling by driving down the cost of sorting and significantly increasing the volume of recycled feedstock that we're producing. And we're doing that, one, by deploying our technology into existing facilities as a retrofit solution, and then also by operating our own facilities, which are designed with artificial intelligence from the ground up. So just before I get into it, I'd like to provide a little bit more background and perspective on AMP. AMP was founded in 2014 by Dr. Matanya Horowitz. We're headquartered in Colorado. We have about 250 employees. We have nearly 300 systems spanning 3 continents globally in more than 25 states in the US. We've attracted top global investment firms, raising close to $170 million to scale and accelerate innovation. Most recently, we raised $91 million in new funding in a Series C round. This was last November, led by Congruent Ventures and Wellington Management. Again, just a high-level summary of some of the impact that we're making. As I mentioned, 300 systems deployed globally. We're operating in 80 Murphs, and that is, as Rushton may remember from one of our earlier conversations, a materials recovery facility. This is where, after your recyclables are picked up at the curbside, where they go to be processed. So materials recovery facility, and then PERF, which is a plastics reclamation facility. So similar concept for plastics specifically. Our artificial intelligence is recognizing 70 billion objects on an annual basis, which is a massive number, and that's objects in all different permutations from all over the world. And then, while not shown on the slide, since inception, our technology has saved an estimated 6.5 million tons of greenhouse gas emissions, and that's an impact equivalent to removing more than 1.3 million cars from our roads. So with that background in mind, let's look a little bit closer at some of the perennial challenges that have faced the material recovery industry. As you probably know, in the US, we have thousands of municipal recycling programs nationwide that are collecting material generated by millions of people. So between the collection and the actual recycling of the commodities, there are really only a small number of Murphs to cope with a tremendous amount of volume. And then a major challenge is that Murphs incur very high costs when attempting to sort out commodities that are continuing to evolve with complex form factors and material compositions as producers push more material out to our shelves for consumption. And so today's Murphs really require a tremendous amount of manual labor and incur high residue loss due to the challenges that they face to ensure high bale quality, which is how they make money. So this all amounts to an erosion in the value of recyclables due to the cost of sorting as the primary bottleneck. So recycling involves infinite variability in the kinds, shapes, and orientations of the objects that you see on a conveyor belt. Training a neural network like we do to detect objects in the recycling stream is no easy feat, but it's an entirely different challenge when you consider the physical deformations that all of these materials undergo by the time they actually reach a recycling facility. They're folded, they're torn, they're smashed, they're partially obscured by other objects. So Neuron, which is our AI platform, uses deep learning to continuously train itself by processing millions of images of all of these materials, building upon an ever-expanding data set that adapts to changes in the facility's material stream. The system can recognize colors, textures, shapes, sizes, and patterns to identify materials based on their visual properties. So at AMP, we now have the world's largest data set of recyclable material for machine learning. And through our fleet of deployments, we identify approximately 6 billion and recycle close to 704 million items a month. And that translates to about 36,000 tons of material. As another example, consider high-density polyethylene, or HDPE. This is a plastic that's commonly found in household cleaning products. So batches of HDPE tend to be mixed in with other plastics, and they may have paper or plastic labels, making it difficult to detect the underlying chemical composition of the object. So an AI-driven computer vision system like ours is able to determine that a bottle is, in fact, HDPE and not something else by recognizing its packaging, using those attributes that I mentioned before: color, opacity, form factor, to increase its detection accuracy, and then even sort by specific color or product. AI can see the packaging at all different angles, including all the levels of dirt, grime, and damage, and it can pick without seeing the entire object. So more identification parameters like this equates to more accuracy. And then within specific material properties, you can target the material as HDPE colored or HDPE natural as a negative or a positive pick, depending on the facility's preference. So you can remove it as contamination if it's in fact non-food grade or has external contamination. So in this way, the integration of AI into the recycling operations provides a very detailed picture of both this one object and then every other object that the AI perceives. With these capabilities of AI in mind, I'll show you a little bit more of a simple explainer of how we're applying it to material recovery. Our flagship product is called AMP Cortex. And again, this is our high-speed robotic sorting system that uses the data generated by our proprietary AI. So there are really three components that you can think of as the eyes, the brain, and the arms. The camera, or the eyes, records material as it comes down a conveyor belt to be picked and sorted. The brain, which is the artificial intelligence that I just described, converts all of these video camera images into data and captures and categorizes everything that it recognizes. And then the software guides the robotic arms to pick and place the material to be recovered. So this is all happening at superhuman speed with consistent precision and extremely high accuracy. As we deploy more robots, the industry then is able to leverage the networked intelligence of these hundreds of units. And then the network effect is collectively or exponentially, increasing this sorting intelligence. So if a challenging packaging type emerges or a new material, we can capture the images of this package and then train the AI to identify the object. And then once it's trained, the knowledge is pushed out or deployed to the entire fleet. So in essence, the more robots that we deploy, the more each customer is helping another customer by expanding the AI's overall material knowledge. And for the videos, the fun part. So here's a look at the entire system in action at a Murph in Roanoke, Virginia. We have 3 robots at this site sorting PET, HDPE, plastic film, cups, and metals. This particular customer was able to stabilize its workforce and capture more of this high-value material, especially during the pandemic, increasing its overall recovery by about 10% with our robots. So most of our deployments are in single or dual stream recycling, recovering paper, plastics, and metals. But we also have deployments in construction and demolition debris, electronic scrap, and organic material. So as I mentioned, this is kind of the first part of the business where we're using our technology to modernize existing materials recovery facilities and plastic reclamation facilities. So this is the robot we've been talking about before, just to give you a fuller picture of what it looks like when it drops in over the conveyor belt. It's picking up to 80 to 120 items per minute, and that's compared with a manual sorter who can pick 40 to 50 items per minute, and not always consistently. We have a variety of ways that customers can acquire a robot. They can buy the system outright. We also offer a leasing program that allows them to unlock the benefits of automation, with a more fixed, predictable monthly cost. There are also a number of grant programs, both on the state and the federal level, as well as coalition funding that consumer packaged goods companies are paying into to help improve recycling infrastructure. So Amp Vision, then, the next part of the system is a computer. This is the computer vision system that facilities can drop into different stages of their operation that will help them understand their material flow from different points in the process. So when it's integrated with our Amp Clarity data portal, which I'll touch on the next slide, users can access real-time material characterization and performance measurement metrics throughout the operation. So with Clarity, it's a solution that we've designed to help our customers better understand the state of their facilities at any point in time. They can track variations in materials or robot performance, evaluate new opportunities throughout their operation, review trends, analyze historical material counts, to better understand their material streams and increase visibility. As an example, if there's a Murph operator that's expecting to process PET, or number one plastic, at a certain rate per hour and it's not meeting that level, Clarity can trigger a material composition alert, and then he or she can investigate what might be causing the drop off, whether it was a truck that came in with more of one material than another, or higher contamination levels. They can get to the bottom of it using these alerts and data. And then our latest solution is called Amphotex, and it is the industry's first AI-powered automation system for film removal and recovery. What makes this so important? The Recycling Partnership estimates that just 1% of households in the US have curbside access for recycling film and flexible packaging today. Yet this type of material is the fastest growing and second largest valued packaging segment. It's everywhere. It's your grocery bags, it's your stand-up pouches, it's the wrapping that goes around the bread that you buy at the bakery. There's close to 95 pounds of these materials that are found in the average US home every year. And these are really problematic because they jam the equipment at materials recovery facilities that aren't designed to handle it. And then that causes downtime. It has to be manually removed. It can be dangerous for the workers. There's a lot of issues that stem from film in the stream. So back to videos. This is one of our deployments in Sarasota, Florida, at Single Stream Recyclers, where they have 14 of our robots in one facility. This is the single largest deployment of robotics for recycling. At SSR, our robots are sorting on fiber lines, container lines, quality control lines, and residual lines. And they're sorting at speeds of 2 to 3 times faster than humans, capable of operating 24/7 if they needed to. The accuracy is upwards of 98%. Worker safety, worker shortages are no longer an issue. Not only does it take significantly fewer people to run one of these facilities with robots, but by design, our robots help create physical barriers between employees, ensuring safe social distancing, which again became really critical during the pandemic, or the early days of the pandemic, when there was a lot of uncertainty about how the disease was transmitted. So with our systems, customers can quickly adapt to sudden volume spikes, both in volumes of material and types of material, and then meet these material demand changes without worrying about things like safety issues, capacity constraints, or added processing costs. Oops. And then one more video for you. This video was shot at a facility in Ohio where we have a customer, Evergreen, which is one of the nation's leading plastic reclaimers. At Evergreen, they are using our Cortex robots to sort green and clear PET bottles. With robots, they've increased purity and consistency and doubled their recovery rate for these bottles at their facility in Ohio. We've partnered with them to install robots at 2 other locations in California and New York as well. And so across these 3 facilities, they now have 15 robots deployed. So I'll turn now to our efforts to expand recycling infrastructure. Our application of artificial intelligence for material identification and advanced automation has matured to the point where it's become feasible to develop what are known as secondary sortation facilities that are economical to deploy and sustain nationally. So through this model, we're recovering mixed paper, metals, and a portfolio of plastics, number 1 through number 7, in different form factors and attributes with high precision and purity. And we have a special focus on plastic blends that are uniquely enabled by AI. So what we do is resell these commodities, including specific or bespoke chemical and polymer blends that processors and manufacturers need to create new packaging from recycled content to different end market buyers. This infrastructure model can economically process and aggregate these smaller volumes of recyclables that are sourced from residues supplied by primary Murphs. So this not only is increasing landfill diversion, but it's giving these facilities another source of income because we're purchasing that material from them. We launched our pilot facility in Denver in late 2020, and we've since brought online 2 additional facilities outside of Atlanta and Cleveland. So AI's precision allows for the separation of many different categories of materials that's opening doors for the industry. So as an example, take PET thermoforms. This is a material typically made from number 1 plastic that's found in things like clamshells and berry containers. There are often limits on the amount of PET thermoforms that can be commingled with bales of more valuable PET bottles. And then on top of that, there's low prices for virgin resin that creates a competitive challenge. And there are buyers of PET bottles that are willing to pay a premium, but that's not always the case with other PET markets like thermoforms. But with AI technology like ours, we can separate out these thermoforms from other PET materials, both for mechanical and advanced recycling and enhancing their value in the process. The technology can do this with a simple software update to the existing install base of robotic systems. These improvements in technology capabilities are creating better end markets and improving circularity for, in this case, a historically challenged material. So in summary, AI is enabling economic improvements to happen via retrofits within today's existing waste management infrastructure. And we're seeing the industry adopt our technology at a rapid pace. And now we're also applying our technology to expand new infrastructure that turns what was previously considered contamination, per my previous example, into these new material markets. So that is all I have prepared. Thank you for your attention, and I look forward to any questions you have.
All right. Thank you very much, Carling. I'm going to introduce the group we've got, and then we're going to get into the rather long list of questions that we've assembled and we'll cycle through. Pun intended. All right. So from our club, we have here in California, Shag Shagrin, our paella master. We've got Lisa Axelrod in Fremont. We have in Italy, our treasurer, Cecilia Babkirk. We have our president, Angelica Morata, and a friend of the club, Aggie, who is with Merced Sunrise and is all inspired because her club did their speech contest this morning, and the young people got up and talked and inspired her, and that's really cool. My name is Rushton. I am the programs chair for our club, and let's get into these questions. So first one that came in from Angelica. What are the potential risks associated with using robots to sort and identify recyclables?
Sure. And I don't mean to defer on this question, but I don't think that there are many risks. I think we're well past the point of AI and robots being seen as emerging technologies. A recent story there's an industry publication called Waste Dive comes to mind that reflects on the industry 5 years after China's national sword policy that I mentioned at a high level at the beginning. And it noted that while robots may have been somewhat of a novelty in 2017, today the industry sees them as a critical investment worth expanding or even redesigning their facilities to accommodate.
So, and a question about that that robot itself. how does it pick up? It looks like there's a
Yeah.
suction kind of component to how
Yeah,
it
that's
picks up.
exactly it. Compressed air. So within that 10 by 10 enclosure that you saw in some of the slides, there is, a camera that sits at the top, and that's the eyes that's looking at and recognizing and, cataloging everything that it sees. And that's just ahead of the robotic arms. So based on customer preferences, whether it's programmed to pick first, number one, plastic bottles, maybe number two, aluminum cans, number three, paper, that can be configured totally based on customers' preferences. The arm then comes down, sucks up the material, and drops it in the appropriate bunker or wherever it needs to be placed to be baled and sold.
All right. Well, multiple questions about contaminants. All right. And so Lisa asked about unclean materials that enter through the machine. So like if people haven't cleaned their bottles or containers properly, and we actually learned in the last presentation about recycling that what we thought might represent proper cleaning of things was often overdoing it. So can you speak to a little bit to that a little bit?
Well, yes, in terms of how the technology works, again, because it's all based on, the visual recognition of, the properties of an object. So the same way that you or I would look at a plastic bottle and identify it as a plastic bottle, that's how the system works as well. So if the contamination is on the inside, that wouldn't, affect the robot's ability to pick it. What that means for, the marketability of the bale that it ultimately ends up in, that could be an issue. But I don't think we see a big issue with contamination with your standard recyclables. I think we see the issue with contamination being more the wish cycling, right? Like people putting bowling balls and Christmas lights and, things that were never intended to be recycled in the stream, because not only does the AI not, have a precedent for how to recognize that, certainly the robot can't pick up those materials and remove them. So a lot of those have to get handled in the pre-sort line, which is the very beginning of that's kind of the first entry point of the Murph. And so robots really aren't suited to that line. That's where people still have to staff to kind of pull out those foreign objects.
Okay. I'm question that came in from Cecilia about some of these pieces. You look at something like, okay, you've got a label that's glued to a piece of plastic.
Mm-hmm.
And this kind of gets us in the general space of how recycling works, at all, right? But how does that affect your processes? I know that AMP is very much focused on, the sorting component, but how does the sorting component work with that question of things that are recyclable, but combined in such a way that perhaps complicates the issue?
So if I'm understanding the question correctly, are we talking about things like a label on a Coca-Cola bottle?
Yes.
So we, the artificial intelligence would look at the shape of the bottle and, the translucency of the plastic. Like it would be recognizing it based on those properties. If it's seen enough Coke or Pepsi or, like a standard, brand label, it's not necessarily recognizing the label, but it's, the red color or the blue in the case of Pepsi, it's seen it enough so that it has confidence that it is a Pepsi bottle or a Coke bottle based on that. So that doesn't necessarily, if anything, that enhances the identification process. It doesn't interfere with it.
Okay.
Actually, where I was going with that is based on something that you mentioned, which is things like laundry detergent bottles that will often have a paper label glued to them, but they are otherwise theoretically recyclable. So I don't understand the process of recycling and what happens in because I recycle things like that all the time. And so when you said early on that your camera can recognize those things, so do you let it go through with the paper label on it? Is that what's done in recycling?
It is. Yeah, I think what would happen, I guess, later on in the process, like those labels don't inhibit the recyclability to my understanding, because we're recycling HDPE bottles all the time. That's one of the most sought after commodities.
Yeah.
If anything, it's just, it just points to the need for some additional training of systems like artificial intelligence to make sure that it has enough, I guess, understanding of the rest of what the shape of the bottle is, or the size of it, or the color, to be able to predict with confidence that this is an HDPE bottle, even though there's a label that, might be interfering with some of the, outer portion of the object or the material.
Right. Interesting. Okay, thank you.
Yeah.
There's a couple of questions that have to do with how, like how the sorting is affected by what the facility can do. So some facilities can handle certain, kind of numbers, in terms of plastic recycling. Others cannot. Why is that the case? Is it just the equipment that they have? And then more broadly, that you do recycling, or you have customers that use your systems in Japan was interesting to me, having been there, where people are really, really into like sorting it themselves. So that made me wonder if there are things about certain countries where the process is easier because of what people do, or perhaps the process is harder because of the way standards for construction of these kinds of bottles and such might make it so that your equipment just can't do that at this stage. Can you speak to that general thing of how different recycling works in different places?
Sure. So I guess going back to the first question, in terms of what's accepted in different communities, that's really a function of what end markets exist. We know where the buyers of the materials are for different commodities. We're not too involved in that process, except in, the case of operating our own facilities, because we have to market and sell those to end buyers as well. But with existing facilities that we are deploying robots into, anything that has been that's in our artificial intelligence system that our system can recognize could theoretically be sorted if the customer wants it to be. So if we're looking in the chat at the question about number 1, 2, and 5 plastic, it really comes down to the location and end markets. So polypropylene, or number 5 plastic, is really an interesting example, because just last year it was upgraded by How to Recycle, which is the body that decides what is considered recyclable or not at a broad level in the US, from check locally to widely recycled, because it met a certain threshold for collection and sortation access. And that's a milestone that took a lot of different stakeholders to achieve, but we're proud to have played a little bit of a part, because our system can recognize polypropylene. So if it's accepted, it can be sorted. And then there's a lot of energy going into developing those end markets, because polypropylene is often found in yogurt cups, margarine tubs. It's a lot of food contact products. So there's a lot of interest from packaging producers and brands to acquire polypropylene PCR as a recycled commodity, so that they can put it back into new packaging. So hopefully that answers a little bit about the first question. Moving to Japan, we do have robots there. Most of our robots in Japan are deployed in construction and demolition applications. And that is because we partnered with a market leader there a couple of years ago, when we decided to enter construction and demolition debris, to train our AI to recognize material. And they were a good person to partner with, because they had a lot of expertise in that area. So that's mostly the robots we have in Japan. I don't think we have any that are sorting single stream or just standard, bottles, cans, paper, that kind of thing in Japan.
Got it.
But I think, to get at your question generally about regional differences, that's huge. And I think in the US, we're all accustomed to what's known as single stream recycling, where we put everything in one bin. That was designed as a convenience for the consumer, but it does create a lot of the problems that we see in recycling, which is variation in programs, contamination challenges, a lot of those things that you don't see in maybe Europe or markets where there's a lot of sorting on the part of the consumer that happens at the front end before recyclables are processed. So I think there's a lot we could say about regional differences, but I think that's the big one.
Okay. One more question before we wind things down, and that's just for you. What inspired you to get into recycling?
I've always been interested in the environment and environmental protection and sustainability. I think I've realized since joining AMP 3 years ago today, in fact, that there's a lot, recycling certainly has many environmental benefits, but there's a real economic role that it plays too in, keeping supply chains intact. And, as much as we don't want to think back to the pandemic and some of the challenges that we went through over the last couple of years. And, people couldn't find toilet paper or, just basic products that we rely on. Like, that's all because we have a supply chain that recycling feeds, that we can go to the store and count on being able to pick up goods that we depend on day to day. So that would be just the broader appreciation for the role that recycling plays is certainly one. And I would be remiss not to mention that, recycling is designed to work in concert with other waste management strategies, reduce and reuse. Recycling is not the sole solution to the proliferation of waste. And we certainly have, that's certainly a challenge that we face. But that's why I always get a little frustrated when I see, headlines about, just doom and gloom headlines about recycling and how we've been misled into believing it works. It does work. There's a lot of interesting technology advancements and innovations that we're working on, that others are working on, that are making it better. So I would just encourage people to remain optimistic about it.
Very cool. Well, we'll hand it back to you for a final word in just a moment. And then once we finish the recording, we'll keep talking to you because we get to do that because we're taking part in the recording. Kudos to everybody on the screen. And so if you are visiting Rotarian, thank you very much for joining us. Please let us know that you were here. There's a little attendance form just a little farther down on the SiliconValleyRotary.com page. And at the bottom, there is a forum where you can share your thoughts on this program and any other element of the meeting. If you are on our YouTube page and you are catching this via YouTube, if you scroll down just a little bit farther, you'll find a link back to our site if you want to learn more about our club. The Rotary E-Club of Silicon Valley can be found at rotary.cool. So with that, we will hand it back to our speaker for a final word. So Carling, please wind us down.
Thanks, Rushton. Again, thanks everyone for being here. Appreciate your interest in learning more about all the exciting things happening in recycling, and thanks for doing your part.
Excellent. Thank you, everybody. We will see you next week.